Hello, everyone. Welcome to a brand new math adventure. My name is Dr. Taha Abdelaal, and today we're going to have some fun exploring the amazing world of 2D shapes and patterns. So here's what we've got on our map for today. We'll kick things off with a welcome, then jump right into what 2D shapes actually are. After that, we'll learn a really cool way to describe them using something called symmetry. Then we'll unlock the power of patterns and even create one together. And finally, we'll see how math is, well, everywhere you look. Ready? Let's get started. All right, so our big goal today is pretty simple, but it's also really powerful. We're going to learn how to see, understand, and even play with all the shapes and patterns that make our world so interesting. By the time we're done, you'll be a pro at recognizing, describing, and even creating your very own designs. Okay, so first things first. What in the world are 2D shapes? Let's dive in and get to know these basic building blocks of, well, almost everything. Think about it like this. A two-dimensional shape, we just call it 2D for short, is any shape that's completely flat. Like a drawing on a piece of paper. It has a length and it has a width, but it has zero thickness. You can't pick it up like a box. And these shapes can be made with straight sides or curved sides, or even a little bit of both. And you probably know a bunch of these already. Let's run through them. Of course, we've got the circle, with its one continuous curvy side. Then there's the triangle, which has 3 sides. The square and the rectangle, they both have 4 sides. Now here's a fun one. Can you guess how many sides a pentagon has? If you said 5, you got it. And a hexagon has 6. See? Each one has its own unique thing going on. Let's zoom in on the triangle for a second. Now, every single triangle has 3 sides and 3 angles. That's what makes it a triangle. But they're not all the same. An equilateral triangle has 3 sides that are exactly equal. An isosceles triangle has just 2 equal sides. And a scalene triangle, it's a bit of a rebel. None of its sides are equal. Isn't it amazing how many different kinds there are for such a simple shape? Okay, how about squares and rectangles? They're kind of like cousins. They both have 4 sides, and they both have 4 of those perfect corner angles, called right angles. But here's the big difference. The thing you have to remember. A square has 4 equal sides. All of them. A rectangle, on the other hand, has 2 matching long sides and 2 matching short sides. Now, talking about sides and angles is great, but there's another really fascinating way to describe shapes, and that's by using symmetry. This is all about finding the balance in a shape, and you see it everywhere, from butterflies to buildings. So, a line of symmetry is basically an imaginary line that you can draw through a shape to divide it into 2 perfect mirror image halves. If you could actually fold the shape right on that line, the 2 halves would line up exactly. That's why some people call it a mirror line. It's like one half is looking at its reflection. So how do you find one? Well, you just have to use your imagination. First, picture a line going right through the middle of a shape. Then, in your mind, fold the shape along that line. Do all the edges and corners match up? If they do, boom, you've just found a line of symmetry. It's pretty cool because some shapes have just one, some have a bunch, and some, like a scalene triangle, have none at all. All right, you know what time it is. It's time for a little challenge. Based on what we just talked about, which of these shapes has more than 3 lines of symmetry? Is it A, the rectangle, B, the scalene triangle, or C, the square? Take a second to think about it. And the answer is C, the square. If you got that right, awesome job. A square has a whopping 4 lines of symmetry. You can fold it in half from top to bottom, from left to right, and you can also fold it corner to corner along both diagonals. That's 4 different ways to get a perfect match. Okay, we've got a handle on shapes. So what happens when we start putting them together? Well, that's when things get really creative. Let's talk about the power of patterns. So what exactly is a pattern? It's really just anything. Shapes, colors, even numbers that repeats over and over again in a predictable way. The key word is repeats. For example, if you have a triangle, then a circle, then a triangle, then a circle, you know what's coming next, right? It's a triangle. That's a pattern. The rule is just triangle, then circle, and it goes on and on. Okay, talking about patterns is one thing, but making them is way more fun. So let's do it. Right now, it's our turn to be the designers, the artists, the mathematicians. Let's make a pattern together right now. Let's decide on a rule. How about this? Square, then triangle, then another triangle. Got it? Square, triangle, triangle. So if that's our rule, what shape would we need to put next to start the whole thing over again? Okay, let's build this thing. Following our new rule, what's the very first shape we put down? That's right, it's a square. And what comes after the square, according to our rule? A triangle, followed by another triangle. Perfect. We've just completed one full set of our pattern. Square, triangle, triangle. So what's the real magic of a pattern? You just repeat. To keep it going, we start our rule all over again. So after a second triangle, we add another square, then a triangle, and one last triangle. See how it just keeps growing? Now I want you to try. Think of your own rule at home and see what kind of cool pattern you can create. We have covered so much great stuff today, and that brings us to our final and maybe our most important mission, connecting what we learned here to the world right outside your window. So let's do a super quick recap. Today, you learned what 2D shapes are all about. You figured out how to describe them like a pro, using their sides, their angles, and even their lines of symmetry. And you saw how we can combine those shapes to make awesome repeating patterns. But you might be thinking, why does this matter? Well, it matters because shapes and patterns are literally everywhere. Just look around. They're in the windows of buildings, the tiles on the floor, the design of a cool t-shirt, even in nature, like a honeycomb or a flower. Once you start looking, you'll see that math isn't just something you do in a book. It's part of everything. So, I'm going to leave you with a final challenge. Right now, wherever you are, just take a look around your room. What shapes can you find? What patterns can you spot? The adventure is just getting started. Keep your eyes open and keep exploring.